Is it cool?
Yeah, it's cold.
Okay, can I bring a heater?
Oh no, don't need a heater, just the wind.
Okay.
Yeah.
Cool.
Okay.
Sorry, are you going to quickly talk?
Perfect. So last bit for today, chapter 5, linear systems. Okay, so chapter 5 is looking at application. So application of the straight lines. Right, so in other words, we're going to be applying what we just looked at, except we're going to be looking at different scenarios. Okay, so scenario where you've got one variable, two variables, or inequalities. Inequalities, remember, those signs. Less than, greater than, equal than, all of that stuff. So when looking at linear systems, the first bit here is obviously get an equation. So when you do these systems, get an equation in order to calculate the x or y and apply to the situation. Okay, so it depends. Again, it's hard for me to say what application you're going to get because there could be so many different types. Okay, the most important thing is obviously you need the equation. Right, once you've got the equation, then you can use the equation to find certain things. Okay. Right, so the first thing is solving linear equations using
variables.
Okay, variables. Right, so basically you're going to be substituting amounts in and you're going to be finding the missing figure. So this is almost like simultaneous equations actually. Simultaneous equations. Right, so finding two variables when we have two unknowns, two equations actually. Okay, so I'm trying to find two equations, two variables from two equations. Okay, so yeah, that's that. Let's find an example. Okay, here's one. Solve the following. Actually, there's only one variable there. We've got two, so we probably need to find both. Let's just check. Are they simultaneous? No, they aren't. Okay, that's not a good example. Let's find one that's better. No. There, simultaneous equations. That's better. Okay, let me use this one. Okay, so y equals, let's copy that. Okay, so do you agree I've got two equations? Equation 1, equation 2. Alright, so y equals 3 minus 2x. And here y equals 2 plus x. Right, so now what am I going to do? Well, I need to find x and y having those two equations. So the first thing is you need equation 1 and 2 to link. Right, so the only way you can link them is by trying to substitute something in. So here I like this, y equals, because now I've got a y there. Okay, so are those two things the same?
Yes.
Yes. So you can say that 3 minus 2x is the same as 2 plus x. Does that make sense?
Yes, that's
Alright.
awesome.
So then I take the negative 2x across. So 3 equals, actually let's take the other 2 across. 3 minus 2 equals x plus 2x. Does that make sense?
Yes.
Okay, so 3 minus 2 is 1. 1 equals 3x. Okay, so 1 divided by 3 equals x. So then now you know that x is a third. Once you've got an x is a third, you can put that third into here or you can put that into there. Doesn't matter. I'm going to put it into here. Okay, so I want y. Right, so then you use your 6 over 2, 6 over 3. Okay, get your common denominator, right? Okay, so 2 times 3 is 6 over 3.
Yeah.
Common denominator.
Yes.
Y here equals 7 over 3. Is that okay?
Yes.
Right, just arithmetic. Right, so where is that? There's it there. That point over there. Okay, so simultaneous equations, one graph there, one graph there. Right, we had x here as 1 over 3. X here was 1 over 3. Right, and then we had, 2, and that is the same as 7 over 3.
Yes.
Okay.
Yes.
Right, that's just simultaneous. There's a few more examples there that you can look at in your own time, and then we can come back to those later on. Alright, just one last thing here in terms of linear equalities with one variable. Okay, if you have greater than and less than. Right, so let me ask you a few questions. Let's say y is greater than 3. What options can you have for y? 4, 5, 6,
7.
anything.
Yeah.
Okay, can y be 3?
No.
No, because it's not greater than and equal.
Yes.
Right, so what happens if you have this? Y plus 5 greater than 3. What do? You treat it like a normal equation.
Yes.
Okay, so you have y greater than 3 minus 5. So y must be greater than minus 2. Does that make sense?
Yes.
Okay, so if it's greater than minus 2, what are the possibilities?
Minus 1, 0.
Exactly.
1, 2, 3.
Yeah, into the infinities. Okay,
Yes.
great. Alright, so that's that. What else is there here? Okay, that's normal. Just one other thing. What happens if you have a negative? If I have negative x greater than 4, and you want x,
Then it's basically minus 1x. So you can...
you divide.
Yeah.
Good, but then you have to swap the sign around.
Yes.
So NB, swap the sign around when using a negative. Okay, right, so this would be, let's even make it 2. Let's do this, minus 2x greater than 4. So what would you do? You would have x less than 4 divided by minus 2.
Yeah.
Okay, so x is less than minus 2. Okay, so just remember to swap the sign around. That's also something else that you need to remember here. Okay, when you do these type of questions. Right, that's all the same, that's the same. Okay, this is just drawing a number line. You know what a number line looks like, okay?
Yes.
Negatives on this side, positives on that side. If you have an open circle, it means I can't have 3.
Yeah.
If I have a closed circle, I can.
Okay.
So this is x less than 3. If it was x less than or equal to 3, then I would have shaded in the dots.
Yes.
Okay.
Yeah. In the previous chapter, they had...
They're like this.
Yeah.
There's one.
Yeah.
Okay. Perfect. Anything else? 2 variables. Okay, so this would be shading in a region. Okay, this is a little bit of linear programming, but not quite. So I just want to see. Okay, that's fine. All right. So if I have an equation like this. Okay, let's actually write that one down. Okay, so when two variables are present in the inequality, right, what must I do? I need to solve it like a straight line. Okay, so here this minus x plus 2y minus 2 is actually a straight line. Okay, so can I write it as a straight line? Yes, but the straight line formula needs y equals ax plus b. That's what I need for a straight line. Okay, so how am I going to get a straight line? I need to manipulate it. So let's move things around. Leave the 2y here. Minus 2 greater than equal to, put the x that side. Okay, leave the 2y there, take the minus 2 across. Divide everything by 2. Y greater than or equal to x over 2 plus 1. Okay, do you know what the y-intercept is?
1.
1. There's the 1. Okay, how do I find the x-intercept? Make y 0. Remember, so if y equals 0, x equals question mark. Okay, so y is 0. So 0 equals x over 2 plus 1. That becomes minus 1, x over 2. Minus 2 equals x. Okay, so there's the x-intercept.
Okay.
There's the y-intercept. Then I connect the dots. Okay, where this comes into it is you need to test. Okay, so when you have greater than or equal to 0, you need to test your straight line. Okay, so what was the equation? Y equals x over 2 plus 1. Right, so now I'm going to test. The easiest point to test is
1.
the origin. Is the origin there? Okay, so I'm going to put a naught here and a naught there. Okay, what is that going to give me? It's going to give me naught. Naught over 2 is naught plus 1. Right, then what was the equation? It was that. Greater than or equal to. I should have written this like that. Okay, like that. Right, greater than or equal to. Is naught greater than or equal to 1? Is naught greater than 1?
Yes.
Naught is greater than 1.
Oh no, it's less
False.
than 1.
Yeah, it's false. It's less than 1.
Yeah.
Okay, so that's wrong. So that means I cannot have anything on this side of the line. Okay, then let's test something on the other side. Okay, so I'm going to test any point on this side. I'm going to test that point. Okay, what are the coordinates of that point? 0 and 3. Right, so let's put 0 and 3 into here. So 3 greater than or equal to 0 over 2 plus 1. That's 3 greater than 0 over 2 is 0. 0 plus 1 is 1. Is 3 bigger than 1?
Yes.
That's true. So that's why this I can have on that side. Okay. Alright, and then that's that. That system of inequalities. Okay, this is looking at the same thing but with multiple lines. Okay, we'll look at examples in the textbook. I don't think they give too much of this, but we'll check when we look at the past papers. But it's the same as what I just discussed. Perfect. Okay, so now we've covered that. Differentiation, I'm going to leave that for next time because it's a slightly different concept. Differentiation is calculus. Okay.